Alright, this is part 3 of this. This is the probability of multiple events. What I'm expecting you to be able to do is find the probability of events A and B, and the event A or B. So we got an and we got an or. That's what you're looking for. To start it off, if we look at this real quick on your own, you and your friend are taking turns rolling a pair of dice. If you roll a sum that is either odd or a prime number, you score a point. If your friend rolls a sum that is odd and a prime number, they score a point. She scores a point. Which score is likely yours? Well, since you can get a point if it's either odd or a prime number, you're going to score more points than her because she has to get odd and a prime number. So you should be player 1 and she is player 2. And then if you try to figure out how many turns each of you has taken, and if you can explain it, that would be good. That's just using probability that you've already done. Alright, so let's move on to this. Find the probability of two events occurring together. You must decide whether one event occurring affects the other event. Alright, so when one event affects the outcome of the second event, they are said to be dependent events. Alright, because the outcome of the second event depends on the outcome of the first event. Alright, when one event does not affect the outcome of the second event, they are said to be independent. Alright, so you have to know the difference between being dependent or independent. That's going to affect your answers and what you're actually going to do. Alright, so let's look at the first one. Are the outcomes of each trial dependent or independent? Alright, roll a die and spin a spinner. Well, rolling a die has no effect on spinning a spinner, so these two are independent of each other. Alright, pick a card from a deck and then pick another card. Alright, picking one card from a deck and then picking another card from the deck. If you replace the card, like you pick it out of the deck and then you put it back in to pick the second one, then they are independent. If you do not replace, then they are dependent. Alright? Because if you don't replace it, then it's going to affect the outcome of what card you picked the second time. Alright? So that is independent and dependent. Alright. On the back you have a U try. That should be pretty easy after I just explained to you that other part with the card. So let's move on and look at the probability of A and B. Okay, so this is our probability formula for A and B. If A and B are independent events, so that's the first thing you got to look, make sure they're independent events, then the probability of A and B is equal to the probability of A times the probability of B. Alright, so as long as they're independent events and you're doing the and, you multiply probability of A times the probability of B. So, example 2. Find the probability of independent events. So at the picnic there are 10 regular sodas and 5 diet sodas in a cooler. There's also a bag that contains 8 bags of fat-free chips and 12 bags of regular chips. If you reach into the cooler and grab soda and then reach into the bag and grab some chips, what's the probability that you get a regular soda and a regular bag of chips? Well, reaching into the cooler has no effect on reaching into the bag, so these are independent events. So the probability of getting regular soda and a regular bag of chips is equal to the probability of a regular soda times the probability of regular chips. Alright, so what's the probability of getting a regular soda? Well, there's 10 regular sodas out of 15 total sodas. Alright, so that's the probability of getting a regular soda. And then a regular bag of chips, well, there's 12 regular bags of chips out of a total of 20. Alright, so we can reduce these. 10 and 20 are both divisible by 10, so we got a 1 and we got a 2, and 12 and 15 are both divisible by 3, so this gives us a 4 and this gives us a 5, and we could just multiply it out. 1 times 4 is 4, 5 times 2 is 10, and then we'd reduce that from 4 out of 10 to 2 out of 5. So 2 out of 5 could be your answer, or 40%. So you got a 40% chance of getting a regular soda and a regular bag of chips. Alright, we got a U-try. So you can go ahead and you can do the U-try. It's based on the same information. Alright, now, two events that cannot happen at the same time are called mutually exclusive. Alright, and again, that's two events that cannot happen at the same time. They are called mutually exclusive events. Alright, so we're going to roll a single die. Alright, that's one dice, a single die. Are the events mutually exclusive? Explain. Okay, rolling a 2 and a 3. So could we roll one die and get both a 2 and a 3? And the answer is no. Alright, you can't get a 2 and a 3 at the same time, so these are mutually exclusive. You cannot roll a 2 and a 3 in a single roll. Alright, so that's what mutually exclusive means. Alright, so you can't do it at the same time. Okay, rolling an even number and a multiple of 3. Alright, this is not mutually exclusive. You could roll a 6. Alright, a 6 is an even number and it's also a multiple of 3. Okay? Alright, so they are not mutually exclusive because you could roll a 6. A 6 is even and it's also a multiple of 3. Alright, rolling an even number and a factor of 9. Alright, well, even numbers 2, 4, 6, 8. Factors of 9, the only factors of 9 are 1, 3, and 9, and none of those are even, so these are mutually exclusive. Now just explain that no factors of 9 are even. Alright, so no factors of 9 are even, so they're mutually exclusive. Alright, and there's a U-try for you to do. Okay, so you can do that. Next, we have our probability of A or B. Okay, so the probability of A or B, we have two formulas for this, right? You have the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay? Now, if A and B are mutually exclusive, all right, if they're mutually exclusive event, then you only have to do this. You only have to do the probability of A or B is equal to probability of A plus the probability of B. All right? So, if they're mutually exclusive, you don't have to do the minus thing. Okay? So, the first thing you have to do is, again, determine if they're mutually exclusive. If they are, you can use this formula. If they're not, you have to use this formula. Okay? All right. Finding the probability of mutually exclusive events. At Sterling High School, a student can take one foreign language each year. All right, so this statement right there makes the events mutually exclusive. All right, because it says the student can only take one foreign language, so they're mutually exclusive. All right, so we got 38% of the students take Spanish, 22% of the students take Italian. What's the probability that a student chosen at random is taking Spanish or Italian? So the probability of Spanish or Italian is equal to the probability of Spanish plus the probability of Italian. All right. So we have to change these into decimals to add them. So 38% take Spanish, so it's 0.38 plus 22%, 0.22. And we add those together and we get 0.6, which is 60%. All right. So the probability of Spanish or Italian is equal to 60%. All right, and then you got a U-try, which should be pretty easy for you. All right, and then we have this one. All right, example 5, finding the probability. Suppose you reach onto a dish and you select a token at random. On the dish there are 2 orange circles, 2 red circles, 1 orange triangle, 1 red square, 1 orange square, 1 green square, and 1 yellow triangle. Just make sure you have the same things on these. Some of these notes are different. We want to know what's the probability you get a token that is round or green. All right, so the first thing we got to do is, are they mutually exclusive? Do we have any tokens that are round and green? We have orange circles, we have red circles, we don't have any green circles, so this is mutually exclusive. So all we got to do is find the probability of round plus the probability of green. All right, probability of round is we have 2 orange circles, 2 red circles, so that gives us 4. And out of 2, 4, 5, 6, 7, 8, 9, plus probability is green, we only have 1 green one. So it is 5 out of 9. All right. So the probability that it's round or green is 5 out of 9. All right. I'm going to do the first U-try because this one I don't think, this one is not mutually exclusive. Okay. So for this one, probability that it's square and red, well, we do have a red square. All right, so this one's going to be the probability of square or red is, again, the probability that it's square plus the probability that it's red minus the probability red and square. Alright, so the probability that it's square, let's say we have a green square, an orange square, and a red square. So that's 3 out of 9. Plus the probability that it's red, we have 2 red circles. We have 1 red square. Alright, so that gives us 3 out of 9 minus the probability it's red and square. We have 1 red square, so 1 out of 9, and that gives us 5 out of 9. Alright, so the probability that it's red and square is 5 out of 9. Alright, and that's it for the notes. So I will send you the homework